Now, something that we discussed is that sometimes we use conditional probabilities to describe models. And let's do this by looking at a model where we toss a coin 3 times. And how do we use conditional probabilities to describe the situation? So we have one experiment, but that one experiment consists of 3 consecutive coin tosses. So the outcomes, the possible outcomes, our sample space consists of strings of length 3 that tell us whether we had heads, tails, and in what sequence. So 3 heads in a row is one particular outcome. So what is the meaning of those labels in front of the branches? So this P here, of course, stands for the probability that the first toss resulted in heads. And let me use this notation to denote that the first toss was heads. I put a H in toss 1. How about the meaning of this probability here? Well, the meaning of this probability is a conditional one. It's the conditional probability that the second toss resulted in heads, given that the first one resulted in heads. And similarly, this label here corresponds to the probability that the third toss resulted in heads, given that the first one and the second one resulted in heads. So in this particular model that I wrote down here, those probabilities P of obtaining heads remained the same no matter what happened in the previous toss. For example, even if the first toss was tails, we still have the same probability P that the second one is heads, given that the first one was tails. So we're assuming that no matter what happened in the first toss, the second toss will still have a conditional probability equal to P. So that conditional probability does not depend on what happened in the first toss. And we'll see that this is a very special situation, and that's really the concept of independence that we're going to introduce shortly.